The Universal Solenoid Driver from Global Electronics Limited is a modularized system that controls multiple solenoids within automotive systems from a user's host computer. Its most common usage is testing and development of automatic transmissions, but it may also be used with other automotive and non-automotive applications requiring precise control of solenoid current. The USD-II, as it is called, consists of a 19-inch wide chassis with a backplane motherboard designed to accept 7 plug-in modules. Several different types of modules are available for use in the rack, depending on the particular application. In many cases, users choose a module that matches the electronics found within their company's own transmission control unit, so that test hardware duplicates the relevant portion of the automobile's electronics. The practical advantage of USD-II is that it allows users to control the module's behavior from their own PC without going through the complexity of a production-level controller that contains so many hardware and software functions unrelated to transmission control. In most cases, the name of a USD-II module comes from the name of the module's integrated circuit that controls the solenoids under command by the user's host PC. For example, engineers working for a company whose transmission controllers incorporate an IC named Adler by its manufacturer Infineon would likely select a USD-II module called Adler because it contains this same IC to control the solenoids. This ensures that the solenoids behave the same way under USD-II control as they do when operated by the vehicle's production controller, provided that users issue the same set of control parameters. As IC manufacturers like Infineon release newer and improved chips for automotive manufacturers to use in production, Global Electronics releases newer USD-II modules that incorporate these same chips. Thus, the Adler module has been joined by newer modules called Adler II and Phoenix, referring, of course, to the Infineon control chips within these modules. Although details differ among the types of IC control chips, and hence among the USD-II modules, the general operation can be adequately illustrated by any one of them. I will use the Adler II module for this demonstration video. One such module can drive up to 4 solenoids simultaneously, each with its own set of control parameters set independently of the other solenoid channels. To control more than 4 solenoids, users just need to add additional modules into the same rack. The types of multiple modules simultaneously operated within a USD-II rack may be mixed and matched according to test needs. In fact, multiple racks may be daisy-chained together if more than 7 modules are required. However, this is seldom necessary nowadays, as recent modules drive 4 solenoids each, unlike earlier USD-II modules that control just 1 solenoid per module. Like most modern controllers, the Adler II chip uses pulse width modulation, abbreviated as PWM, to achieve variable degrees of on in the solenoid, as opposed to older solenoid controllers that were strictly on or off. However, unlike earlier PWM controllers, the Adler II need not be commanded with a duty cycle percentage. Rather, this sophisticated chip varies the PWM percentage automatically in a closed-loop control fashion so as to achieve the commanded average current through the solenoid. In this first shot of the oscilloscope, the PWM voltage applied to the driven side of the solenoid is seen in the yellow trace, scope channel number 1. The resulting current flow in the solenoid appears in the blue trace of scope channel 2. Note that when the solenoid is momentarily turned on, denoted by the low voltage on channel 1, current begins to flow within the solenoid. Of course, it rises slowly because of the solenoid's inductance. Similarly, inductance keeps current flowing after the voltage drive is turned off, 12 volts here, and it drops gradually until the voltage across the solenoid is reapplied. The example just given may seem confusing until it is remembered that the IC controlling the solenoid is a low side driver, meaning that the opposite end of the solenoid is connected to a steady 12-volt supply, like the vehicle battery in automotive installations. Thus, when the voltage applied to the drive side of the solenoid shows as 12 volts on the scope, the voltage across the solenoid is 0 or off. When the voltage on the driven side of the solenoid is near ground, about 12 volts appears across the solenoid, turning it on. In this present example appearing on the oscilloscope, the Adler II chip within the USD-II module has been commanded by the host PC to maintain a solenoid average current of 600 milliamps, about half the full-scale range of this particular chip and solenoid. Note that the Fluke current meter in series with the solenoid shows precisely this value of current achieved by the USD-II. When I increase the value of desired current commanded by my PC to the USD-II chip from 600 milliamps to 900 milliamps, the chip automatically increases the duty cycle so as to obtain the target current value as seen on the current meter and scope here. A feature of the USD-II chip, shared by other modern chips, is the ability to apply a so-called dither waveform on top of the DC solenoid current. This AC component of current, more like a sawtooth than a sinusoidal variation actually, allows the current to fluctuate above and below the average commanded current. Its purpose is to minimize stiction within the solenoid's valve mechanism, which if not mitigated by dither current, tends to resist moving smoothly to a newly commanded degree of opening. Like other parameters, the frequency and amplitude of dither is controlled by commands sent from the PC to the USD-II. In order to see the effect of dither in action, I first slow down the oscilloscope sweep to view mini PWM cycles because the dither frequency needs to be much lower than the PWM frequency. As I turn on dither, you can see the variation up and down of average PWM current according to the amplitude I commanded. If I increase the amplitude of commanded dither from my PC, the effect is seen immediately on the oscilloscope. If you wish to discuss technical aspects of the USD-II system, please contact Global Electronics Limited, who will put you in contact with their product technical specialist.